Okay, so this is ECO419 Computable General Equilibrium Models. Welcome on board. Uh, this is our first class, so we're gonna go over the syllabus and we discuss what this course is all about. What are my expectations? Uh, we're gonna briefly discuss the contents, which topics to cover, etc. We already discussed the meeting IDs and Zoom info and other stuff such as office hours and etc. Communication information. So let me show you the textbook cover. So you can, I think, find this book over the internet using either legal or illegal channels. But this is a very nice text. This is, what I find, most student-friendly approach to general equilibrium. Okay, um, and this is indicated in syllabus as well. Check first the university resources. Start try connecting to library services so you can perhaps access it, or you can buy it online, etc. So this is uh, I purchased the online version some time ago. All right, so this is the text, and let me open the syllabus now. Okay, so the course description is here. Basically, you are going to learn the fundamentals of general equilibrium theory, and then you also learn how you use general equilibrium models to think about real-world issues. Okay, so most of the stuff we are going to do in this semester will be about applying general equilibrium models to several problems, including fiscal policy problems, environmental taxation, um, and other type of interesting problems. So um, the important issue here is that in general equilibrium modeling or general equilibrium theory, we are interested in equilibrium in all markets, right? So that's the defining aspect of general equilibrium theory, not just one market, not just three markets that are connected somehow. We are interested in the existence of equilibrium in all markets, and not just the existence, of course, but also um, the stability of such equilibria. Why are we doing that? Why are we interested in the equilibrium of all markets, equilibrium in all markets? Uh, because by heart we know that these markets are connected through several mechanisms. The most obvious one is that the goods and services are substitutes and complementary to each other, right? So there are several goods that are complements of one good. There are several goods that are substitutes, and in some cases, these goods are perfect substitutes or perfect complements. Sometimes the elasticity of substitution is equal to 1, sometimes is less than 1, sometimes greater than 1. But this is the most obvious channel that imply interconnectedness between different markets, among different markets in the economy. So when we develop a general equilibrium model, when we construct a model of general equilibrium, we basically connect these markets to each other through different channels. Obviously, it is a micro-founded approach. So we go to the individual level and we try to understand the behavior or the choices of households, individuals, firms, sometimes the choices of central banks, sometimes the choices of government. Okay, so all the agents can be modeled, and by doing this, by creating these causal mechanisms, we can understand the transmission channels of policies and shocks, right? That's the idea. So if the COVID-19 pandemic hits the economy, what is the transmission mechanism that create the economic effects? Okay, so if you are using a general equilibrium model with, of course, micro foundations, you can trace these propagation mechanisms. All right, you can understand what is the initial impact and why. You can see what is the medium term impact and why, and you can see what is the long run effect and why. But of course, we want to use general equilibrium theory through the models that we can actually solve. Okay, um, so we need solvable models. So models should be interesting enough by touching to reality, of course, but also they must be simple enough to be solved and analyzed. All right. Um, so we try to understand still. So this is such a realist philosophy of science. So we are trying to understand the real world, but we are going to use a model, uh, uh, a thing that we can understand perfectly, and a thing that we can teach to the computer, right? So the machine will also understand uh, the model, and then we are going to use it to develop some arguments, to develop some conclusions. Some of them are empirical, some of them are theoretical, etc. So the contents, okay, now I realized, okay, all right. Okay, the content. So first, today, we're going to very briefly discuss why this theory of general equilibrium is based on mathematical models. There are good reasons, but you know, the use of math by economists is always controversial. Uh, we discuss some pros and cons of using math. Then today, I want to introduce you two things. First, the neoclassical theory of value. You actually know it, you use it all the time, but perhaps you never call it this way. All right, perhaps you never label it as the neoclassical theory of value. Then we're gonna understand a common property of all general equilibrium models, which is what I call dual core. So in the dual core, we have two properties. First, agents optimize. Okay, so whatever agent you are modeling, those agents will have objective functions and they will optimize those objective functions by making optimal choices. Okay, that's one part. And the other is markets clear. So all the markets will arrive at an equilibrium point. So that's where and how we define the general equilibrium. All right. So today's discussion will be about why use mathematical models, what is neoclassical theory of value, and what are the main common properties of all general equilibrium models. Then next week we're going to discuss the positive properties of Lorentzian equilibrium. All right. So these are existence and uniqueness and stability. Okay. So we're gonna ask, how do we know a general equilibrium exists? We're going to ask, how do we know whether it is unique or not? And then we're going to ask, how do we know one general equilibrium that we found is stable? Stable in the sense that if for some reason, because of a shock, because of a policy change, etc., if the economy is distorted so that the economy moves away from equilibrium, how can this economy go back to equilibrium back? All right, or whether more specifically, whether the economy reach the original initial equilibrium. All right, so that's the question of stability. After discussing all these three properties, again, existence, uniqueness, and stability, we're going to discuss the welfare properties or the normative properties of general equilibrium or the Walrasian equilibrium. So in the second part of this course, in this part 2, right, we study the simple Walrasian model. All right, in the simple Warezine model, um, we directly work with the demand functions. Okay, then we're gonna see in part 3 a very simple toy model. Okay, in this toy model, we will have one household, one firm, one good, and one factor. So this is one by one by one by one model. All right, which is a toy model, which is not very realistic, but that gives us the foundations of what comes next. All right, because in part 4 we're going to go back to the textbook and we're going to study a much more realistic model, still perhaps not very realistic in some aspects, but it will have households, it will have uh, firms, it will have a government, etc. Right? So it will have, of course, multiple households, multiple firms that produce multiple goods, and one government that taxes the firms or the households and then distributes the tax income through transfers. All right. Then we're gonna extend this model in part 5. We're gonna introduce external sector, which means international trade. We're gonna introduce labor market. We're gonna introduce some consumption technologies, etc. Then in the last 3 parts, part 6, social accounting matrices, part 7, calibration, and part 8, CGE models at work, we're going to discuss the applied aspects. Okay, social accounting matrices will be used to take these models to the data. Okay, because in the data we see the accounting data, right, of households, firms, government tax assets. So we're gonna create this uh, social accounting matrix for an economy, and we use that matrix that also, includes information about firm level transactions. One firm is purchasing a particular firm's good as its intermediate input, for instance. All right. So we use that data to understand how we can learn about the particular economy at a particular date. Right. Uh, Here we are talking about different geographies, of course, and different time periods. But most of the time, since this is an introduction class, we are going to work with static models. At the very end, maybe we can discuss some dynamic general equilibrium models. Then we have calibration. Calibration is a method. Uh, in some respects, it is close to econometrics, but in some other respects, it is much different. So I will show you what it is, what is the main principles of calibrating general equilibrium models using social accounting matrices and other data. So calibration basically sets the numerical values to our parameters. Okay, because as you know, in all models we have some parameters, alphas, betas, and gammas, and those are basically theoretical constructs, of course, but they have, in such micro-founded models, they have particular meanings, right? So then calibration is a method that lets assign values to such parameters. Okay, and then we discuss particular uh, applications of CG models: fiscal policies, trade policies, stabilization policies, and environmental analysis. All right, so that's the overall part, overall content. Some of the parts we may not have time, or if we all agree that we should focus more on this thing, maybe we can go that direction. So in the original syllabus that I designed for the first time for this class, I actually included a dynamic general equilibrium part at the very end, but later I realized that 14 weeks is not enough to cover dynamic general equilibrium. But if we have time, I will show you the simple mechanics of dynamic general equilibrium models as well. Okay. So, any questions regarding the description or the contents for the class of the class? So, if you have no questions or anything to add, I will go back to my whiteboard and talk briefly about models and mathematical models and the foundations of general equilibrium theory. Okay? So let me share my whiteboard with you now. Okay. So does everybody see my board?
Yes.
All right, great. So what you see on the lower panel here is a box, of course, and this box is the model. This could be any economic model. All right, so that's important. Uh, this is of course an abstraction, but it covers under appropriate, of course, um, extensions. This covers the main story about economic models, right? So what you see here. So let me change the color. Okay. So what you see here. Oops, this one. So this is alpha, right? Alpha is a parameter. In any economic model, we have a set of parameters. Parameters are constants of the, let's say, universe, right? So in physics, for instance, there are some constants about gravitational forces, right? So in economic models, we also have structural parameters. Some of the parameters describe preferences of people. Some of the parameters describe production functions of the firms. Some of the parameters describe how the government behaves in one particular domain. What is the government prefer? What does the government prefer, or what does how does it set the tax rate, etc., etc. Right? So in all models, there are some things that we assign particular meanings and that we use mathematical formulas and usually the Greek letters such as alpha, beta, gamma, theta, epsilon, etc. Right? So these are called structural parameters or simply parameters. We also have what we call exogenous variables, right? Exogenous variables. Türkçesiyle dışsal değişkenler. So exogenous variables are not fixed, but they are given to us. So the basic definition is this. So these are the variables whose values are determined outside the model. All right, so the modeler or the economist or the theorist basically takes uh, these values as given. So they can change in time. They can change from policy to policy. They could be variables that can that can be hit by shocks. Okay, but basically these are taken as exogenous variables whose values are determined outside the model. So what does the model then do, right? That's the question. So model is like a box. So there's one hole right here, okay, on this side of the box. So you put your structural parameters, all right, structural parameters go in, and then you also supply the model with your exogenous variables, and the model is basically a set of equations, okay? Those equations are generally in this form, okay? So those equations establish the causal relationships between exogenous variables, endogenous variables, and alphas. So Y is the set of Okay, so okay, I would require you to not to use whiteboard. Okay, uh, Yusuf, I think it was you. Could you please undo? All right, let me. Okay, I cannot change it. Anyhow, let me continue. So why? Oops. Y is the set of or the vector of endogenous variables. Endogenous variables, by definition, are those variables whose values are determined within the model. How? Through the relationships, okay? Through the economic relationships that is represented here by this function f, okay? So of course, there are more than one function here, possibly because there are more than one endogenous variable. But any economic model basically uh, is reduced down to this. All right. So then we're gonna solve the model. Solving the model means finding this function f. Okay. When I solve the model, I express all my endogenous variables y1, y2, y3 as a function of exogenous variables and structural parameters. Okay. So believe me or not, but this is true for any economic model. Okay? This is true for any economic model. And that kind of actually summarizes or signals us why we use mathematical models. Because we are working with quantifiable objects. Right? In economics, we are working with quantities, prices, most of them. We are working with those things. So all these quantities and prices that can be actually measured, they can be actually quantified, right? So we can actually, go to the central bank's website. You can actually, download the entire sequence of, for instance, dollar exchange rate against Turkish lira, right? So since we are working with quantifiable objects, the best thing we can do, perhaps, or again, this is subject to uh, long methodological or philosophical discussions, but mathematical models are particularly useful because we know how can we go from this capital F to this, all right, this little f. So we know what describes my economy, okay, this f function, which tells me how uh, exogenous variables, endogenous variables, and structural parameters are related. And then when I solve this set of equations, I basically know the solution. Okay? And only after this, only after knowing that, I can actually look at this animal. All right? You know what this is, right? So this is a partial derivative. So if I want to understand the exogenous variable xi's effect on endogenous variable yj, I can use this partial derivative, and to use this partial derivative, I must have the solution. Okay? We must first find the solution, then I can um, analyze such derivatives. So this is called, maybe you can remember this from your earlier lectures, this is called comparative static analysis. All right, so I change the exogenous components of the model, exogenous variables, and how those exogenous variables would affect endogenous variables. All right, how can government expenditure affect national income, for instance, right? In the ISLM model. Remember the ISLM model is one model like this. So you have exogenous money supply, exogenous government expenditure, and some autonomous consumption and investment expenditures. You put all these things in the model, and you have, of course, relationships among economic variables, as you see here, right? So in the Keynesian model, you have C0. So this is simple ISLM model, right? So you have something like that. Government expenditure is autonomous. Let's say investment is there's one autonomous component, and then there's another component that depend on interest rate, etc. Right? So when you put all these equations together, you finally find consumption, let's say, as a function of autonomous investment, government expenditure, and let's say money supply. All right, things like that. Again, investment is a function of this, income is a function of this, right? So this is basically what a model does. And math helps us in going from this, okay, to this. That's basically it, because we formalize our assumptions by using this f function, okay, this f function here. So let me now go back to. Would you like to ask any questions about these things? Okay, let me save this very quickly. And let me open a new page. So I will stop sharing and reopen again. Okay. So the idea of general equilibrium is due to oops. Okay. I'm still all right. Oops. Due to Walras, Leon Walras. So Walras was the first economist to imagine a mathematical model where all the markets are connected to each other, okay? And in his theory, which was a simple version, of course, it was not general enough. So it was a general equilibrium in the sense that all markets are clearing, but it was not. I mean, not all of it was micro-founded, but he imagined what would happen if we try to make all markets clear, right? So this was at 1874. Then there were, of course, others, but most importantly, Kenneth Arrow and a French mathematician, Gerard Debreu, generalized the Walrasian model by using modern axiomatic approach to microeconomic choice, okay, choices. So they try to generate this model by using preferences of households and production sets of firms. Okay? So in the Walrasian model, what we see only demand functions, but after like a century later, 80 years later, we see a model where those demand functions, those excess demand functions for each good is actually, originating from the constraints and preferences of firms and households. Okay? So Arwen constructed that model and proved the existence of the equilibrium. All right, proved that there is actually a general equilibrium under these certain conditions. Of course. Then, of course, this is just theory, but then, Scarf, all right, Scarf at 1973 developed some algorithms for computation. All right, because we want to. So you imagine. So if you want to clear all markets, we are talking about a really large economy here, right? There are many different markets in the economy. So if you want to do something serious about using this theory, try to apply those things to real world, you must have many sectors. All right. So computation of equilibrium then is an important task. It was an important challenge, but Scarf used an algorithm, developed an algorithm, and then some other economists contributed to that literature as well. So now, after 70s, we know how to teach those models to a computer and how to let computer to compute our variables of interest in equilibrium. Right? So this is you will see in a couple of weeks why this was a daunting task. Because in 70s, computer systems were not as developed as today, right? So there was this problem as well. So let me check how much time we have. Okay, we have around 4 minutes. So let me now go back. Do you have any questions about these foundations? So if you go back to the textbook and read the first chapter, you'll see, you will understand the main story. There are also other textbooks, other sources that you can read the history of general equilibrium. So I can actually recommend you some readings if you are interested. There are history of economic analysis or history of economic ideas journals, so you can actually go back there and read some interesting history of economic analysis papers. There's one nice book by Till Dupe. I guess it's a philosophy book, but it explains the philosophy of general equilibrium in a very nice way. But the main historical foundations are these things. And there are, of course, other people, other important people. There's one American economist that actually worked very closely with these in early 50s as well, but most of the success is now referenced back to Arrow and Deborah. Okay? So, let me... If you have no questions or comments or anything to add, I will go back to my whiteboard and show you and talk a bit about the neoclassical theory of value. All right. So.
Are we going to reconnect?
Yes. Thanks for asking. So, after this record session ends, let me just check. So we have about 2 minutes. Then let's say we're gonna connect back again at 10:50. All right?
Okay.
10:50 good for everybody? It will be a 10-minute break.
Okay, it's
all right. So now let me discuss. Go back to my whiteboard. But then we are going to connect again at 10:50 after this ends. Okay. So what do you see here? So what do you see here is what you always saw during your studies, right? So this is a demand and supply figure for a market, right? So you have the inverse demand curve, you have the inverse supply curve, right? This is quantity of the good in the market, and this is the price of the good. So what you know by heart is that under certain conditions, of course, there is an equilibrium here. Okay? And in that equilibrium, we have an equilibrium price, which I call here, denote here by P star, and then there is an equilibrium quantity, which we denote by Q star, right? So think about this during the break, and we will use this very simple thing, very simple construct, after the break. Now it is 10:30. Let me stop sharing, and now let me also stop recording.